Alright, your skill check corrections. If you will, make notes on your paper. First problem. We have 5 times x minus 4 plus x plus 2 equals 12. So looking at this problem, it looks like we do have a 5 outside the parentheses that we need to distribute. So that'll be our first step here. Distribute the 5 to the x, distribute the 5 to the negative 4. So we have 5x minus 20, it looks like. For your other set of parentheses, we do not have anything on the outside except for a plus sign. So if you want to think about it this way, you could say, hey, I'm going to distribute that plus sign. Or you could just drop the parentheses. It means the same thing. So plus x plus 2 equals 12. At this time I can simplify, so I can put my 5x and my x together, so that would be 6x, and put my negative 20 and my 2 together, that's going to be negative 18. That's going to equal 12. If I add 18 to both sides, then I'm going to have 6x equals 30. Divide each side by 6, so x is equal to 5. So here's problem number 2. In part A, it is saying I need to find m of 6. So again, thinking about this notation here is telling me that I have the input of 6. So I can take this 6, put it in as my input to the m function. So that's going to be 1 divided by 6 minus 4 in parentheses. 6 minus 4 is 2, so in which case I have 1/2, which is an acceptable answer, or I could say 0.5. Okay, part B. Part B says that I have j of x equals 27. Now in this case, remember these are a little different. For these type of problems, they're giving us the output. So I take the output and I plug it in for my j of x. So really what it is telling me is it's telling me I have 27 is equal to 8x minus 5. I'm going to add 5 to both sides, in which case 8x equals 32. Divide each side by 8. So x is equal to 32 divided by 8, I think is 4. So there's your two solutions, 0.5 for A and 4 for B. And make sure you are copying down all the work for these problems. Okay, I'm not going to make a screenshot of number 3, but I will just quickly draw out the graph. And it looks like at negative 3, negative 4. Negative 3, negative 4 is the point. And then it kind of goes down like such. It goes to the edge of the paper, so we assume there's an arrow. And we need to, in this case, find the domain and the range. So domain, just setting up. So remember, smallest number less than x. Having some computer difficulties here. Less than x, which is less than the largest number. And then I have the range, same thing. Smallest number less than y, less than the largest number. Squiggly bracket. So as I fill in my values here, looks like I have on the x-axis, looks like the smallest number farthest to the left over here, I think is negative infinity. And then the largest number looks like the farthest to the right would be at negative 3. Now it is a filled in circle, so I do have to put in the dash underneath. For the y-axis, it looks like the smallest number here is going to negative infinity. And it looks like the largest number on my y-axis is at negative 4. And again, I need that dash underneath. So again, remember your format. It's the smallest number, which is less than either x or y, depending upon if you're doing your domain and range, which is less than your largest number. For the domain, the smallest number would be the number farthest to the left. Largest number would be the number farthest to the right. For the range, it would be the lowest number for the smallest, the one on the bottom of the graph, and then for the y-axis, the largest would be the highest one, or the one farthest on top. Alright, for this one here, we're supposed to expand the quadratic. Expand means I need to multiply it out. So you could use the FOIL method, or we could use a generic rectangle. As I look at papers, majority of us are doing the generic rectangle. There's a couple of us that are doing FOIL method. Alright, so if I do this, I'm going to have x minus 2 on one side. I'm going to have 2x minus 5 on the other. And I need to find the areas. I need to find the area inside each one of these boxes. So for this top left box, I need to do 2x times x, which is 2x squared. When I do the top right box, I have negative 5 times x, which is negative 5x. Bottom left here is going to be negative 2 times 2x, which is negative 4x. And negative 2 times negative 5 is positive 10. So if I add my x's together here, I'm going to have a negative 9x. So putting the values in order, I have 2x squared minus 9x plus 10, it looks like. And there's my expanded equation. Now notice, these two are equivalent. Both those equations are equivalent. They both describe this rectangle right here. Just two different ways of writing it. Alright. Next problem is a factoring problem. So if you look back in your notes, we know that we need a diamond problem and a generic rectangle. Doesn't matter which way you draw these, you're going to need them both. Some people put the generic rectangle first, other people put the diamond problem first. Doesn't matter. Remember to find your top value. What you need to do is you take the first times the last, and that's going to be the top, so it's going to be a negative 6x squared. Remember your bottom value is the x's, so that's going to be a negative x. And I might as well just fill in my generic rectangle right now. Generic rectangle, I have a 6x squared in one corner, and then the opposite corner would be negative 1, and then the two values that I find in my generic rectangle will be the ones that I put in the two other corners of my generic rectangle. Okay, so let's find the two in my diamond problem. I need two numbers that multiply together to be negative 6 and add together to be negative 1. I believe that if I do negative 3x and a positive 2x, if I multiply those together, I do come up with negative 6x squared. If I add those together, I do come up with negative x. So I can put those right in my corners. So I have a negative 3x, and I have a 2x. And then to figure out the outside of the generic rectangle, I just factor. So if I factor going across this way, it looks like I have an x and I have a 2 that is common, and then I can just fill out the rest of the generic rectangle. 2x times something equals 6x squared. Well, I think that is going to be a 3x. 2x times something equals 2x. Well, I think that's just going to be a 1. 3x times something here is going to equal negative 3x. I think that's a negative 1. And my last corner there, negative 1 times 1 is negative 1, so therefore I know this is my factored form. 2x minus 1 is one factor. 3x plus 1 is the other factor. And again, like we said before, this equation right here is exactly the same thing as that equation. Just two different forms, because they both describe that general general rectangle. Okay. Alright, for problems number 6, 7, and 8, you need to watch the second video on simplifying exponents.